Hello, everyone. I posted another task in Google Classroom. And in this task, you will need to know a little bit about something we call correlation. You might already know a little bit about correlation. In this video, we're going to define it, and we're also going to use some different words to describe different kinds of correlation. So what I would like you to do first is do this warm-up problem. In this problem, you are given a table that shows the age that a person is and the distance they were able to throw a discus. And what you're going to do with this data is create a scatter plot. So you're going to plot all this data, then you're going to answer this question at the bottom. Do you think the distance an athlete can throw is related to their age? So go ahead and pause the video, take some time to make your scatter plot, answer this question, and when you're ready to move on, you can unpause the video. Okay, so the scatter plot should look a little something like this. So I made a scatter plot in Desmos. And so on the left, you can see the X's and the Y's in a table, and your scatter plot should look a little something like this. And it looks like, yeah, as the age of the athlete increases, the distance that they can throw the discus also increases. So it looks like there is a relationship between the age of the athlete and the distance that they can throw the discus. And we would say that in this situation, there's a correlation between these two variables, a correlation between the age and the distance thrown. So let's go back to our slides here. And what we're going to be doing in this video is describing certain correlations like the one we just saw. And in the task that you're going to do after this video is you're going to come up with a way to determine the strength of a correlation. So you're going to come up with your own way to calculate a number that describes a certain correlation. So correlation is a part of statistics. So in statistics, one way that we can use statistics is to determine how two different variables are related to each other. So for example, age and distance thrown would be two variables that we saw are related. And we saw this in the warm-up. And again, we saw that as age increases, so does the distance thrown. So this relationship we can describe as a correlation, which is basically exactly what we just described, the relationship or association between two variables. Now, there are a bunch of different ways that we can describe a correlation, one of them being the direction. So we can have a positive direction where as X increases, Y also increases. That's positive correlation. We can have a negative correlation where as X increases, Y decreases. And we can have no correlation where there's no relationship between the two variables. In the warm-up, we saw a positive correlation, but negative correlations also exist. So that's direction. We also have linearity. So if the trend is linear, meaning that we can draw a line to describe the relationship between the two variables, we call that a linear trend, but not all trends are linear. Here's an example of a non-linear trend, this guy right here, and we can see that the curve that best describes the relationship is not a line. For our purposes, we will just be focusing on linear trends. How do we describe them? How do we describe the correlation? Eventually, we're going to want to be able to actually write an equation for that line that describes the trend. We won't do that today, but eventually we do want to be able to find an equation for that line. We can also describe the strength of a correlation, which is how closely the data follows this pattern or trend. If the trend is linear, then the closer the points are to that line that we draw, the stronger the correlation is. So we can see that we have strong correlations over here. This is what the data would look like if we had a strong correlation. We could see that those points very closely follow the line. We could have a moderate correlation, where the points still follow that trend, but they're a little bit further away from the line. We can have a weak correlation, where we can see that the trend still exists, that there's a positive or a negative correlation between those variables, but the points are very spread apart from each other. We sometimes see outliers when we collect data. There are really sort of two different kinds of outliers. If an outlier is the result of a recording error or a graphing error, we should always remove that data point from our data set. Otherwise, it should be kept. If it's a genuine piece of data, then we should always keep it with our data set. We're going to see here that this point is an outlier. It does not follow the trend, but this point right here is not an outlier. And why is that? Well, even though it's far away from the rest of the data points, it still follows the trend of the data. It's still on that, it's still close to that line that describes the trend of the data. Okay, so I'm gonna have you guys do a short problem here. I've given you 3 different scatter plots. And for each scatter plot, I would like you to comment on the existence of a pattern. So is there a positive, negative, or no correlation? I would like you to comment on the strength of the relationship here. So is it 0, weak, moderate, or strong? Describe whether the relationship is linear and whether or not there are any outliers. So go ahead and pause the video and comment on each of the scatter plots addressing these 4 different things. Okay, so this first scatter plot, it looks like there is no correlation at all. There doesn't seem to be any trend here, meaning that the strength is 0. Because there's no trend, we cannot describe this relationship as linear, and we can't really say whether there are any outliers because there's no trend. This middle scatter plot, it looks like there is a positive correlation, and that the relationship is moderate. It doesn't look strong, but it doesn't look particularly weak. Somewhere in the middle, moderate. It does look linear. It looks like I can draw a line to describe the trend here. So we're going to call this linear. And it does not look like there are any outliers. So no outliers. And finally, this last scatter plot, it looks like there is a negative correlation because the points trend downward as x increases, y decreases. This looks like a strong correlation. The points all seem to follow and be pretty close to not a line, but some kind of curve. So this curve is definitely not a line, so we would say that this is not linear. And there does seem to be one outlier. Okay, a short note. We've been talking a lot about correlation, so correlation between 2 different videos. I feel it is my duty as a mathematician and in some certain contexts a scientist to make sure that it is clear that correlation does not necessarily imply that there is a causation between the 2 variables. So there's any number of examples we can see of there being a correlation between 2 variables, but one variable does not cause the other variable to change. So maybe, yeah, as you get older, the older you get, that causes you to be able to throw a discus further. But we can see here that there's a correlation between the number of people who have drowned by falling into a pool and the films that Nicolas Cage appeared in over time. And in fact, we can see that there's a pretty strong correlation. Those numbers seem to match up pretty well each year. But of course, people drowning in a pool does not cause Nicolas Cage to appear in more films. And Nicolas Cage appearing in more films probably doesn't cause more people to drown by falling in a pool. Here's another example. The divorce rate in Maine correlates with the per capita consumption of margarine. And of course, one does not cause the other. These two things are very, very far apart from each other. Just one more. The MAP doctorates awarded correlates with the uranium stored at US nuclear power plants. But of course, one does not cause the other. These are really silly examples. If you'd like to see more of these, there's a link to a website called Spurious Correlations in the Google Classroom assignment. You're welcome to take a look at those. Okay, so let's go back to how we describe correlation. We can describe the strength of a correlation by describing it as strong, moderate, weak, zero. But this is not always a very precise way of measuring the strength of a correlation between two variables. So for this reason, we have a specific value that we can calculate that we call a correlation coefficient. And this correlation coefficient should tell you the exact strength of the correlation between two variables. In general, we use R to represent this number, the correlation coefficient. So this number R will range from -1 to 1. So it can be positive or it can be negative. The sign of R, so whether it's positive or negative, indicates the direction of the correlation. So a positive value of R should indicate that the variables are, of course, positively correlated. A negative value of R should indicate that the variables are negatively correlated. So that's one thing. The sign tells you whether the correlation is positive or negative, but also the size of R should tell you something about the correlation. This should tell you about the strength of the correlation. So if your value of R is close to 1 or -1, that should indicate a strong correlation. If the value of R is close to 0, that should indicate a weak correlation. So the closer that R is to 1 or -1, the stronger the correlation is. So here's sort of a more visual description of what we're talking about here. We can see that when R is equal to 1, or when R is equal to -1, that should be a perfect correlation. All of the points are on that line that describes the trend. If R is within 0.05 of 1 or -1, that indicates that you have a very strong correlation, either positive or negative. You can see that the points are very close to that trend line. Between 0.87 and 0.95, we would call that a strong correlation, or between -0.95 and -0.87. And then between 0.5 and 0.87, we would say that that is a moderate correlation, or between -0.87 and -0.5, a moderate negative correlation. Otherwise, so values between 0.1 and 0.5, or -0.5 and -0.1, we would call that a weak correlation. Anything between -0.1 and 0.1, we say that there is no correlation. Okay, so this value R should tell you both the direction, whether it's positive or negative correlation, and also how strong is that correlation. So knowing this, you guys are now going to complete a task. So you're going to need to find the drive-in movie theater problem. It should be attached in the Google Classroom assignment. Go ahead and open that up now. Okay, so in this task, Jack, a movie theater owner, carried out 3 surveys. he plotted the results of the surveys as 3 scatter plots: scatter graph A, scatter graph B, and scatter graph C. These are given on the pages that follow. So if you scroll down, you should see scatter graph A, which is the ice cream sold versus the outside temperature. You should see scatter graph B, the snacks sold versus the soda sold. And you should see scatter graph C, the number of viewers versus the length of the movie. Okay, for all of these scatter graphs, you're given the graph itself, but you're also given the actual data. So the coordinates for each of these points. The first thing you're going to do is describe the correlation that each graph shows. This is exactly what we were just doing. You're going to describe whether it's positive or negative. You're going to describe whether it's strong, medium, weak, 0. You're going to describe it as best you can. In problem 2, Jack wants to find a way of measuring the strength of the correlation for each graph. So he's going to try to calculate this number R somehow. And so he says, draw a polygon around all the points. The area of this polygon is small when the correlation is strong. The area is large when the correlation is weak. So a good measure of the correlation is 1 over the area of the polygon. And there are some problems with this. So you're going to think about these problems, and you're going to explain some of the problems with Jack's method. And you might want to use these examples here, or examples that you can come up with, to explain why Jack's method might not be the best method. After you've done that, you're going to describe a better method than Jack's for calculating the correlation of each graph and explain why your method is better. We didn't actually talk about a way to calculate this number R that should be between -1 and 1. And that's actually what you're going to be doing here, is you're going to try to come up with your own way to calculate this correlation coefficient R. Now, while you're doing this, you need to remember that R should be between -1 and 1. If it's positive, there should be a positive correlation. When it's negative, there should be a negative correlation. And the stronger the correlation, the closer this value R should be to either 1 or -1. So based on how you describe each of these scatter plots, whatever method you come up with to calculate this value R should tell you whether the correlation is strong, weak, moderate, and whether it's positive or negative. There is no one correct answer here. It's not like there's a formula that I expect everyone to individually be able to come up with. There are many different ways that you could go about calculating this coefficient. You're going to come up with your own way. Actually, on that topic, I would really recommend that you work on this with a few other people. It's going to be a lot more helpful to bounce ideas off each other and come up with your way to calculate R as a group. Again, there's no one correct answer to this. So whatever method you come up with should be valid as long as you're finding a value between -1 and 1 and it describes the correlation. One other thing, please do not go past page 4 until you have finished problems 1 through 3 on the first page. Once you have finished problems 1 through 3, you can move on to page 5 and start answering the other questions that are in this task. But that is it. There are some reflection questions at the end. When you are finished, please submit and upload your assignment in Google Classroom, and I can give you some feedback. I hope you are all doing well. You're staying safe out there. Please feel free to email me with any questions or comments. But yeah, best of luck.